Hello everyone. Today we are going to discuss a small concept tricks that is standard error of least square estimates. So first of all, we should understand what is standard error. So standard error is nothing but the standard deviation of the sampling distribution of the estimate. It is nothing. It is only the standard deviation. Standard deviation, you know that the summation xi minus x bar. This is deviation of the sampling distribution of the estimator. Estimator is what? Beta 1, beta 2 hat. And the sampling distribution estimator is simply the probability distribution or frequency distribution. That is a distribution of set of values which is obtained from the different sample with samples of n same size from a given population. The set of values of the estimator obtained from all possible samples of the same size from a given population means, let's suppose there are 100 sample, 100 population. From 100 population, we have taken 5 samples having with each 10 items. Means there are 50 items we have already taken in our 5 samples. And the set of data, and the data which are in their each sample, we can use them to derive the value, and the value is derived from each sample. As a result, we have a set of different values of the estimator. That is simply saying that it is a distribution of the set of values of the estimator obtained from all possible samples of the same size from a given population. So sampling error is used to check the reliability and precision of the estimator, that is beta 1 hat and beta 2 hat, because these are because beta and beta 2 are the values which are not changing or which are not varying from different sample to sample. It varies, but the data varies from different sample to sample. Due to data varies different sample to sample, as a result, the beta 1 and the beta 2, beta 1 hat and beta 2 hat, the values of it are depend upon its data. Though since the data varies, as a result, its estimator will vary. So uh, there is some needed. There is something which is needed to check the reliability or precision of the estimator beta and beta 2 hat. In statistics, the precision of an estimate is measured by the standard error, that is SE. In short form, we have called that SE. Second point, that is the variance of beta 2, that is sigma square by summation xi square. We always should know that the value of variance beta 2 hat is always positive. Where the third is the use of covariance in OLS. What is the use of covariance in OLS? We know that the value of estimator, that is beta 1 hat and beta 2 hat, will not vary from different sample to sample. But in a given sample, its values depend upon different data, and they are likely to be dependent in each other. This dependence being measured by the covariance. This dependency is measured by the covariance between them. So the covariance of beta 1 hat and beta 2 hat, that is minus x bar, variance beta 2 hat. So we have already know the value of beta 2 hat, that is sigma square by summation xi square. We have written that. So we know that this is variance to beta 2 hat is always positive, it cannot be negative. And the nature of the covariance between beta 1 and beta 2 depends upon sign of the x bar. We know that the value of beta variance beta 2 is always positive. But the nature of the covariance between beta 1 hat and beta 2 hat is depend upon x bar. If it is negative, then the covariance is negative. Sorry, if x bar is positive, as the formula shows that the covariance is negative. If x bar is negative, the covariance became positive. Means that is, if the slope coefficient beta 2 is overestimated, the slope of the beta 2 hat is beta 2 is overestimated, that is the slope is too steep, that is the slope is too steep. If the slope is too steep, the intercept should be so small to manage it. So the beta 1 should be underestimated. That will the intercept will be too small.